Okay, so we would like to talk about this linked list, and the main thing is why I would like you to have an idea about it, because so far when we have a lot of data, the main storage that we've been using is an array. Now we're using array list. We used array list, which was kind of fine because it helped us not have to program some of the things that we will have to do. Let's say if I had a very long list. Imagine I have a list of 1 million values, and I would like to insert some value in the middle. Now you have to create a new array with 1,000,001 to have some enough space for this extra value that we'd like to insert in the middle, and then copy all the values in the new array one by one, all those that are before this position that you'd like to insert this new value in, and then add the new value and then copy the rest. So it's a lot of copying though. So if you have 1 million values, you're going to copy 1 million times. And what if you insert another time? So it's going to be something that is not really efficient. So people will try to think, okay, what if I have this type of things and I will have to insert things in the middle a lot? The array is going to be very time consuming. I will always have to copy, create a new one, copy the old ones, create a new one, copy the old ones, which is time consuming. I would like to find a better way. A better way is this. What if instead of doing such a thing, we just have some kind of a list of elements that are linked together? We will create some class. Every class will have two parts. The parts when I put in the value, and the other part that says who's next. And if I put like this, like just going to use it with two numbers, let's say, I'm just saying that this is the first one. Next, after that, there's this one. If I'm adding another one, well, fine, and just keep adding. Now this is the third one that's going to be added, and say, okay, now this one points to here. The last one, there's nothing afterwards, so we just refer to it as it's empty or null. There's nothing afterwards. But then the advantage of this thing is that if I'd like to insert somewhere here, let's say, it's kind of very easy. I don't need to do a lot of copying, because what I'll have to do is the following. I'm going to create a new element, a new object, give the value, put the value that I'd like to put in, and then this one needs to be just now changed to be here, while this one is going to be here. And I will just remove this one. And this way, I was able to insert inside in the middle of the list without a lot of efforts. However, I mean, for every element, I will need to remember which one comes next. And that's how it started, the idea of this linked list. Now, this is called a singly linked list. There are other lists, there are other type of linked lists, but let's focus on this just singly linked list. What if we would like to program something like that? Let's try to do that. We'd like to program a linked list, so I'm just going to create a new project. I'm going to call it a linked list. And let's create a new class. This class is going to be my linked list. So in this linked list is going to hold all this information, but each one of the list will need to have like this kind of element. Now this element generally is referred to as a node. So I'm just going to create a class that is going to be called node. Now that class is going to have two things. Let's say I'm going to make things simple. This is going to be an int, and this is going to be another node, because it just refers to another node. That's how we can put these links between them. So this is the value, and I'm just going to make it node. This is the next. Now I'm going to make them private. So that's all I have. What I'm going to do, basically, I'm going to insert some constructors, one that initializes them all. I'm going to maybe add one that has only the value. It just, if you give me the value, the other one is going to be this dot next is going to be null. Why? Well, you know what, just remove this. We'll add it when we need it. I'm just going to add just this constructor so we can initialize these, and that's it. Now every element now for us is a node. Now this node is having two parts, a part that has the value, this is the one, and the other part that has this, what's the next node that is going to be. The next node is a node, right? So that's why this has to be a node that's going to be the next one, and that's how I'm going to be able to see which one is next. But what if there is no next, like this one? It's going to be null. For me, null means nothing is going to be, there's no next, the next node. So that's how I will be able to do this. However, I need something else. I need to know where the node starts. I need to have something that tells me, looking for this one, something that tells me here from where the list starts. So this is commonly referred to as the head. The head of the list, that's the one. So I'm just going to show, okay, this is the head. And the head is part of the list. So now this is done with my node. I'm just going to do this for now. If I need something, I'll do it later. But now this is going to be just my list that is the linked list will be having. I'm just going to make it easy for me. I'm just to make it public, okay, just not to work with too many things that are private. I'm going to make a node that is going to be my head. Now this linked list, I'm going to initialize it. When I initialize, well it just starts by putting the head to be null, which is already null, but anyways, this is what happens when I'm initializing this linked list. But then what I'd like to do, I'd like to be able to add things to the head. So let's just start. I'm just going to erase these, no, like this, and then in the main, let's close others. Now in the main here, I'm just going to create a new linked list. This is my list, equal new linked list. Now I'd like to add some elements. Well, this is what I'd like to do. I'd like to have a method called add that is going to be adding this 5. And when I'm adding this 5, what I would like to happen is that now when I create this line before this add 5, I'm going to have in the linked list the head that is null. It points to, well, there's nothing, so it's null. But now after I click on add, I add this number, it's going to create a new node, and this new node will be having, let's say I said I want to add 5 to it, so I'm going to be putting this 5 here, and then the head is going to be this one. So how to add this add? Well, I need to do put some code in that, so I'm going to make it public void add and then int the value that I would like to add. So what I need to do now when I'm adding a new value, I need to add a new node, right? So I'm going to add a new node by creating this node, new node, equal, or maybe node, let's create n, equal new node. And that new node, I'm in the value where it's going to be the same value here, the number, but then the next, what is going to be next? For me, it's null. So once I add this new value, this is what I did. I just added this new value. What I need to do now is that I need to put the head to point to that new value. So now this is going to be head equal n. So far, so good. But what if I'd like to add another number? Let's say I just would like to add, after add 5, I'd like to add 2. Now, according to this same code, this code, what is it going to do? It's going to create a new node. So it's just going to add this new node, put 2 inside of it, null here, and then the head, put it here. So this is not what is going to happen is that this head is going to, instead of pointing here, it's going to be pointing here, and then I lost this 5. That's not what I would like to do. What I'd like to do is what? Now there's 2 things that I can do. When I'm adding these 2, should the 2 be after the 5 or before the 5? After. Now if I do it after, that means I need to add to the end of the list, right? So which means now it's not the head that is going to be needed to be having this to be the link here, but it's this number here, 5, this node 5, that needs to change the next to be this new node.
The 5 is become the head.
Because now the 5 should be now the head. So what I need to do now is create this here, which is fine, and then this 5, how can I get the 5? Well, I have the head that goes to the 5. So what I need to do is the head.next is going to be n. Oh, here this is going to become a little bit crazy. Head.next. This is head. The head points to this. .next means this place here. And this head.next, I'm going to put this to here, this n, this new node that I just created, which means this is what basically it does. But I cannot do this because sometimes the first time when it's empty I would like to do this. When there's something I'd like to do this. When there's one element I would like to do this. So there's should be some cases that I need to put some kind of an if. If what? If this is the first time, how I know this is the first time? If the head is null, I'm just going to make this new node that I'm created to be the head. But if it's not, that means there was something before. Head.next is going to be my n. And now I have successfully did something that works with 2. You see that there's something weird because it might not work with 3 and 4 and 5, but at least with 1 and 2 it's going to work. Okay, for us to be able to see that, we'd like to be able to print what's inside the list. How can we do printing inside the list? Well, we'll try to find a way how to print a list. Actually, because this node, it doesn't have to be public because I'm not accessing it directly. So I'm just going to leave it as private. I don't need it to be public, so if I need it, I will make it public. Now I don't need this one. I'm just going to keep the minimum that I need. Now I would like to be able to print print the list of all elements in the list. How can I print the list of all elements in the list? Of course this should be public. Void print. So this print, I need to start from the head, and while the head is not null, I will just keep moving and display every element one at a time. So what I'm going to do, I'm just going to have a node. This is going to be my I that is going to change. This node n equal the head. So I'm going to say while. Why did I use a node n, not head? Because I don't want to change the head. I want to leave it as it is. And I'm going to say while n is not null. So if the node is not null, maybe I can just make it node here. Are you fine with this? It's lowercase node. This is a variable of type node, so it's going to be maybe clearer than the n. It's much better than just n. But what I'm saying, if this is not null, for example, if I'm here, this is not null, okay, then I'm going to display maybe just on the same line node dot the value. Then I put a space. Okay, but after this, I would like to go. Now I displayed this node dot value. I would like now to go to the next one.
Are you sure?
Well, there is some kind of increment that I can do, but it's not like the same. But I can do this. Look at node.next. Node.next, this one here. Now I said the first time the head is going to be my node. Okay, so this is my node, and it's going to point to the same place. Is node different than null? Well, yes, it is. Then display node.value. Node.value, I'm going to display 5. Then what I'm going to do is that node is going to be node.next. Node.next, that means this one that points to here. So node.next is this, and I'm going to say this node.next, make it my node. So now my node is going to point here. And then what I'm going to do, I'm going to ask, is node different than null? Well, yes, it is different than null. Then display the node.value, which is now it's going to display 2. And then node is equal to node.next, which is this place here, node.next. But this one is null, so when I'm come back here, is not different than null? No. Okay, so I get out and I go back to the line, and this is going to print the list. I can make it a little bit fancy by doing something like this, like the array list. You remember the array list? It just displays something like this, and without going back to the line. And then I'm just going to print this one before and this one after. So you're going to see something that is going to be like starts here, closes here. We're very excited. Let's try that. First of all, this is our list, and this is going to be list.print, and let's run, and here it is. There's a space here before, so because every time I display and I put a space, I'm going to put a space here, so it's just going to be okay. Now what if I have only one of them? It is going to work. And what if I have none? That's fine, it's an empty list. So it seems to be working regardless of how many items I have. However, now this add here is not going to work all the time, because now if I have a third element that I would like to add, let me just clean this a little bit. If I have a third element that I would like to add, let's see if I add another one, what is going to happen. Let's say I add 7 here. Based on this code, this is going to create a new node with 7 and then null. So this is going to create a new node with 7 and null. Is the head equal to null? No, the head is not null. So I'm going to go here. Head.next is going to be node. Head.next, this is head.next. I'm going to put it to node, which means I'm going to remove this one from here and put it here. Now if I do this, I just officially deleted the 2, because now after the 5 there's 7, and if I just run this, as you can see, 5 and 7, the 2 is gone, even though it stays in the memory somewhere, but I completely lost it because I don't have any direction to it. So what I need to do is I need to do something better. What is something better? Instead of me starting from here, imagine I have 1000 numbers. I need to go from the head to add to the back of the list. It's kind of a long way to start from the head and then so next. I need to go to the back. So there's a better way. Maybe I should have something that tells me where the list starts and where the list ends. So something that mentioned this is where the list ends. This is the tail. They refer to it as the tail. And every time when I'm adding a new one, I just add this new one, and then this tail is going to be, I'll put this here, and then this tail now move it to here. That would be much better. And that's basically what I'm going to do. Just to make it easy on me, I'm just going to have now, instead of only just head, I'll have head and then tail. And in the beginning, the head and tail are going to be null. But when I add the first one should be here. Now I just would like to correct my code before. Now I'm going to remove this one. I said now I have two things, head and tail. Now the first time this should be like this. So if this is null, the head is going to be the node and the tail is going to be the node. This is going to do the same thing. Just put these two variables to the same place. But now when it's something like this, I'm not going to change this one. The head is going to stay there because I would like to add to the back. So the head is not going to change, but the tail is going to change. Now if I'm creating a new one, the tail, let's say this is the 2, what is going to happen is that this tail should change to this. But before it changes, I need to have this one point here. This is the tail. What I'm going to do is the tail.next is going to be the node. This is what I'm doing here. This is doing this link here. And then the tail is going to be my node. The tail is not this one, but this is the new one that I just added. Now this way, every time if I add a new one, let's say the 7 that I would like to add here, what is going to happen is that is the head null? No. So just go the tail.next, you put inside of it this node, tail.next that was here. So tail.next is going to be this new node. Then the tail is going to be my node, so which means remove this. Now the tail is going to be my node. And this is how I can successfully add to the back of the list. Now if I run this thing, I will see 5 to 7, and if I keep adding, it will just keep going. But notice the effort. It's not like a simple add. And this is basically, there are two ways to add to this list. I can add to the back, but I can also add to the front. And each one of those has a set of code that I need to deal with it. So there's an advantage. I can put something in the middle quite easily, but there's a disadvantage in terms of the programming. It's kind of more efforts into programming this. And by the way, if you're getting dizzy, this is just the first class of data structures, which is the Java 3 that we commonly refer to here. This is the first class. When you're going to be looking at these codes and having a lot of fun. And this is only one type of linked list. This is the simplest linked list that you can have, because there's another one which is much better, but instead of only going from the head to the tail, there's one that goes both ways. So you have next, you have previous. So if you'd like to go back, you can go back, but because this one you can only go, I mean, in one direction. You cannot go back from the other direction. So again, if you'd like to have now this next and previous, which means you have to come back here, and instead of the node, instead of the node having only the value next, you're going to be having the value next and previous. And of course you have to deal with the code that does that. But for the scope of this course, I'm not interested into going into all these things, right? But I would like you to know that it involves some heavy efforts in terms of designing the methods. Well, luckily there are some methods that are already available. I can use, instead of this linked list, or that is mine, there is a linked list that is provided by Java. And unfortunately I'm just this is the one that is going to be mine, but because I would like to import that, so I think it's in Java is it util linked list? Here it is. This is a linked list that is going to be, let's use, this is a generic class that is going to be new linked list. And now this list, I'm using this java.util, so because I am using the same name that this class that is in my project, and NetBeans could not import that, so could not make the difference between the two, so that's why I'm using the complete the package and the name of the class, so I can explain which class I'm interested in. Now you can see this list dot, and you have this here. You see, you have this add, or you have add first, add last, and each one of them you have this clear contain, which gives you true or false if it finds something, get an element at a specific place, position, index of, get first, get last, and all these. Let me give you an idea about how this looks like. Let's have a look at this linked list. Now you're going to see that this is working with the node, and this is the node that has the item, and then this next and previous, and then the constructor. That's all it needs. But then let's have a look at this add. If I'd like to add, let me close this, is mine. Let's add a number, or add to the last. So it's add 5. Now this add last, it's just going to call a method called linked last, and linked last, just create a new node and put the last one into it, and this is the new one with the new value that we put in it. And notice there's this one here. What is this? This node here has 3 elements, because this is the previous, this is the element, and this is the next. So it's, anyways, a lot of efforts in there, but it's going to be able to add things. So you can add these numbers to the last every time. So whatever you add, now what if I would like to display it? Well, I think they have the toString that is going to be able to display that for me. I'm hoping, yes. So how can I see this? Let's have a look at the toString. So we can go to it much faster. Now this toString, this is what it does, is just do some kind of fancy stuff. So my point here, there are different data structures that allows us to store data in it. The most basic one, and the one that we've been using for so long, is the array. The array is very helpful because I can directly get access to any element, but there's a problem if I'd like to insert something in the middle of a long array. I have to do a lot of processing. Now this processing takes some time, so if the data is become very huge, the array is not going to be feasible data structures to hold my data. So another type of data structures are the linked lists. These linked lists are different flavors. Let's say there's the simple one, is the one that we've been seeing, just to have like one next to the other, and then this is called a singly linked list, so like singly linked list, and the other one is doubly linked list, which has like double linked. But this, as you have seen, it involves a lot of processing. You have to prepare the class, or at least understand how the class works, and it takes a lot of efforts to do that as compared to the array. That's all I would like you to know, and I would like you just to be able just to also know that if you have a linked list, what are the things that needs to be done if you add an element, a new element here, what should be done. If you delete an element, what should be done, things like that. For example, now if I have this list here, and this one points to this one, and this one points to this one. Now if I'd like to delete these two, what should happen basically? Well, just if I delete these two, what I should take is that this, instead of pointing to this one, it has to take this value and then point it to here. But you need just to know the basics of this linked list. That's pretty much it. Nothing really complicated. But the main idea is it needs every node needs some kind of a link to the next. This is like the simplest linked list that you can have. If you would like to add another one, now you have the ability to go back from each one. You just remember who is next and who is previous to that. So now you can know, for example, this 5, who's next? It's 2. What's previous? Well, there's nothing. And the same thing with the 2. Who's next? Well, there's the 7 that is next. And what is previous is the 5. So because it takes you back to, you can go back in both ways. So that is the introduction that I would like to talk about. I'm not going interested into getting into a lot of these details because it's not really worth it. You'll have a lot of time looking at that, inshallah, next semester if you take these data structures. And you're going to see a lot of these things, but you have to, the basic idea is the same. Nothing fancy. Yes.
Can you explain the advantage of the tail?
The tail? Yeah, the tail actually, you see, because no, it's just like the nodes. When we were doing this adding, you see, we're always adding here. Let's say this 5 here that I added, and then when I added another one, I had to take this and put it to the next. But imagine now I have like 100 numbers. I would like to add this. Now, if I start from the head to go to next, until there's so many of them before I find the last, so I can add the. So there's one that is pointed here. Let's say 7 and 8. This is pointing so many, and then this is the new one that I'm adding. So instead of me trying to go from the head to the last one here, so I can just put this link here, it will be much easier for me that every time I just remember which one is the last, which one is the tail. So if I remember that this is the tail, instead of me going from the head to the last one, it's easier for me to come from the tail and say, okay, this is from the tail, and this is the last one. Use it to link the new one to it. That's why this tail actually was used. So you can just easily go to the back of the list. And that's why we just do this easily, because we're already in the back, and then we just move to the back again. Well, that's pretty much it. What I'd like to talk about this linked list, that's all I would like you to realize, is that it's kind of heavy on processing as compared to an array, but it has the advantage of being able to handle the list, and especially insertions in the middle are kind of straightforward. I don't want to show you the code about how to do that, but you can guess it's just like take this, make sure that you don't forget. I don't want to get you mixed up with the details, but you can see that it's kind of easier to insert in the middle than with an array.